Well, in this video, we will be looking at identities, right? Grade 11. Even if you're not in grade 11, you will still benefit from this video. Well, identities play a vital role. Yes, they play a vital role in trigonometry. We use them in expressing or simplifying expressions as well as proofs, right? So that's where we use our identities. So in grade 11, we focus on two identities. One, it's what we call a square identity. Secondly, it's what we call a quotient identity. You need to know both of these identities. From the square identities, there are two identities that when we derive, we can find. But we'll look at that in practice. If you're new to this channel, guys, what are you waiting for? Kindly subscribe, like, comment, watch the video until the end, and pause and attempt the question, then check whether you did well. In that manner, you will be learning, right? Be a student, not a follower. What do I mean when I say be a student, not a follower? It's good to follow people, but what is most important is to learn from them. I hope, guys, you're doing that, but that doesn't mean that you shouldn't forget to subscribe. You subscribe, like, comment. It's free of charge, guys. Right? Let's get into this video. Let's get to this video. Consider you're given sine squared theta plus cos squared theta, which is equals to 1. This is what we call a square identity. We call this a square identity. So from these, two identities will come. So let's make sine squared the subject, then we transpose cos to the other side. So this will be 1 minus cos squared theta. Whenever you're given 1 minus cos squared theta, write sine squared theta. Then we can also make cos squared theta the subject by transposing sine the other side. So we're going to say 1 minus sine squared theta, right? Whenever you're given 1 minus sine squared theta, write cos squared theta. I hope you are getting what Mr. Richard is saying, guys, right? So this is what we call a square identity. We call this a square identity, guys, right? I hope you're getting it. Then we have what is called a quotient identity, which is 10 theta, which will it's sine theta divided by cos theta. So whenever you're given tan theta, always write sine theta. Whenever you're given sine all over cos, always write tan. So it's very important to note. Another thing, guys, in terms of the function tan, they will ask you where it is undefined. They really love that, especially in trigonometric functions, right? So even if in proofs as well, there are those questions. You'll tell them which values where it's undefined. Where it's undefined, guys, it happens where if cos is what? It's equals to 0. So if cos is equals to 0, just know that this is where it is undefined. This is where it's undefined, right? So I hope Mr. Richard has explained that very well. These are two most important identities. Let's look at our practical examples that will help us. Consider you are to express, let's say they say express the following. Express tan, let's say they say tan theta plus cos theta divided by 1 plus sine theta. Most students or learners, they are afraid of fractions. But it's the same fraction that you did in grade 4. The same fraction that you did in grade 4. 1 plus 1 all over 2. You know that here it's the same as 1 all over 1. Then LCD, your LCD, it's 1 times 2, you get 2. It's what? It's the same. It's the same. You don't have to be afraid. Whenever you're given a fraction that has addition or subtraction, just find an LCD, right? So in this case, before we attempt to an LCD, because they said express tan theta plus cos theta divided by 1 plus sin theta. So usually they will say express it as a single trigonometric ratio. So considering further, the equation will express it as a single trigonometric ratio. So what I'm going to do, guys, I want you to put that in your mind. Put that in your mind, right? So because you are given tan, remember I told you tan is a quotient. You change it. Change it to what? Sin theta divided by cos theta plus cos theta divided by 1 plus sin theta. Remember what I told you. Whenever you're working with fraction, addition, or subtraction, find an LCD. Find an LCD, guys. Your LCD will multiply the denominators. Cos theta multiplied by 1 plus sin theta will be our LCD in this case, right? So, since we have an LCD, we have to put an LCD downward. So this will be cos theta, guys, 1 plus sin theta. Because we are dealing with addition, we can cross multiply. Similarly, even if you are working with this, you can cross multiply, right? The best way, a quick way will be to cross multiply. So this sin theta will multiply 1 plus sin theta. Then we also have plus cos theta, cos theta as well. So from here, we can continue further by saying sine will multiply everything that is inside the bracket. So if we say sine times 1, that will be sine theta. If you say it sine times sine, that will be sine squared theta. Then cos times cos will be cos squared theta. I hope you are getting me. Cos theta. We also have 1 plus sine theta. Can you see from here? Can you see that there's what we call a square identity? Remember from what we learned, whenever you're given sine squared plus cos squared, it is equal to what? 1. Then let's go here. Whenever we see this, so step, we're going to say put 1 where there's sine squared plus cos squared divided by cos theta 1 plus sine theta. Can you see that we have the same thing? This and this thing and this thing is the same. Sine theta plus 1 and 1 plus sine theta is the same thing. So what do? We cancel. We are left with the numerator 1 there. So this will be 1 all over divided by bani, or divided by cos, guys. Divided by cos. So let me write it very well. 1 divided by cos theta. Yeah, 1 divided by cos theta. This is how you simplify or express trigonometric ratios. Check, guys. If they give you a fraction, check whether you have to find an LCD or not. Also use your identities very well, right? As we have seen from this example, there were 2 identities that were needed. There was a quotient identity. There was also what we call a square identity. Let's proceed to a proof. Yes, in this video we'll look at proof, as well as what do we call this, an expression, or a way of simplifying an expression, right? So without wasting time, let's continue. Consider you are required to prove. Consider you're required to prove 1 minus cos theta divided by sine theta, which will be equal to sine theta and 1 plus cos theta. So you have to prove that 1 minus cos theta divided by cos theta divided by sine theta, which is equals to sine theta plus 1 plus cos theta. 1 plus cos theta. In this example, guys, we can see it's impossible. It's not possible to simplify each side. From the left-hand side, is there anything that you can change? Is there any identities? Nah. On the right-hand side, is there any identities? Check very well. Here you have 1 minus cos theta divided by sine theta. Is there anything that you can change? Nah. Here, nah as well, right? So, such, we will use what we call a conjugate. Do you know what is a conjugate? A conjugate, it's sort of a couple. It's sort of a couple. A couple of 1 minus cos theta, it's 1 plus cos theta. So in this case, let's say I'm working with the left-hand side. Let's say I'm choosing the left-hand side. Mr. Richard preferred to choose the left-hand side. So if I'm choosing the left-hand side, remember I'm having 1 minus cos theta and divided by sine theta. So I'm going to use a couple of 1 minus cos theta, which is 1 plus cos theta. I will then multiply the numerator and the denominator, right? Multiply 1 plus cos theta, the numerator and the denominator. I hope you are getting me, right? So from here, let me start with an LCD, multiply there, sine theta, and 1 plus cos theta, denominators there. Then we can see that we have two difference of two squares here. Why I'm saying so, we have 1 minus cos theta and 1 plus cos theta and 1 plus cos theta. This thing reminds you of difference of two squares. Why I'm saying so, you'll understand it better. Because we have x squared minus y squared, we are going to say x plus y and x minus y. So if you are given this, your couple will be this. So that's why I'm saying this part is a difference of two squares. So to make life easier, I'm going to multiply out 1 times 1, that will be 1. It will be same as 1 squared. Then negative cos times cos, that will be negative cos squared theta. So it's because it's a difference of two squares, it's kind of simple. You don't have to go writing a lot of steps in terms of multiplying out. Nah. So divide by sine theta. Divide by sine theta, guys. 1 plus cos theta. So what is 1 minus cos squared theta? Remember from what I told you, whenever you're given 1 minus cos squared theta, it's the same as having sine squared theta. From our square identity, right? So we are going to put sine squared here. And we're having what here? We're having sine theta as well as 1 plus cos theta. Are we getting there? Yes, we are getting there because we have sine theta there. We have sine theta there. So, but it must be a single as sine theta only, not sine squared theta, right? So what do? We cancel. We are only left with 1 sine theta here, divided by 1 plus cos theta, right? So you will have proven this. So this is how it ends, guys. See you on the next one where we are going to look at other proofs. Do not forget to subscribe and like, and remember, we love you.